All right, this is example 5.3.1. It says you've got forces of 10 newtons, 50 newtons, 25 newtons, and 30 newtons, and it wants to find the net force or total value of these to bring it into equilibrium. So let's go ahead and take a look at this. Remember, we are trying to find another force value to make it such that the sum of the forces is equal to 0. So let's take a look and see what we have. We have a 10 Newton force to the right. We have a 50 Newton force to the left. We have a 25 Newton force up. And we have a 30 Newton force down. So right now, as we see, we have a net of a 5 Newton force down and 40 Newton force to the left. So in order to bring this thing into equilibrium, what I'm going to need is a 5 Newton force up to cancel this and a 40 Newton force to the right. Let's go ahead and draw it like this. So these two forces combined will cancel out these leftovers. So what I have to do is I have to find the value of this particular force right here, this one force. And then I also need to find the angle that it's exerted at. So we talked about this earlier when we talked about projectiles, but you can do the same thing with force. If you have two forces that are perpendicular to each other, you can use the Pythagorean theorem, or a squared plus b squared equals c squared, to solve for one of the sides. Additionally, you can use the fact that you can say the angle is equal to the inverse tangent of the opposite over the adjacent side. And these are both review formulas that we talked about earlier with projectiles. So now let's take a look at this. You'd say 40 squared plus 5 squared equals, you want to take the square root of that to get your answer. And over here you'd have the inverse tangent. This is the angle I'm looking for, so the opposite side would be 5, divided by the adjacent side would be 40. So we enter it into our calculator. We say, okay, 40 squared plus 5 squared take the square root of it, and you get 40.3 newtons at, we take a look at our angle value, say the inverse tangent of 5 divided by 40, and you get an angle of 7.1 degrees. And this would be 7.1 degrees up above the right direction. So this is the angle right there. So this right here represents the one force that could bring all of these forces into equilibrium.